GKN Driveline is an automotive components manufacturer specializing in drivetrain technologies. GKN's local site in Newton, North Carolina is home to 2 plants which manufacture differential rings and pinions and fabricate drivetrain components. With multiple assembly lines, training new employees proves to be a cumbersome process. As such, GKN is seeking a simulated assembly station to help familiarize new employees with the basic tools and station behaviors they will encounter. As a Phase 2 team, our objectives for this project involved improving upon the design of the previous team and finishing the assembly of the station. The preliminary design drew inspiration from the assembly station shown, which is a part of the assembly process for a BMW X5 front drive unit. The station involves the use of a Bosch Rexroth nut runner to torque the fill plug, and a 10 kN Kistler servo press, which is responsible for simultaneously fitting the head bearing race and tail bearing race to the differentials housing. When the Phase 1 team had to bench the project due to setbacks related to the pandemic, assembly of the station had just begun. Throughout the past 2 semesters, our team has worked to improve upon the preliminary design, bringing us to the model shown. With designs and schematics in hand, the team worked in the lab laying out and wiring the controls cabinet, fabricating new parts, and performing integrity checks against our plans. And this is the resulting product. Among the aforementioned hardware, the station also features an optical safety finger switch to prevent unintentional activation, light curtains to ensure the press is clear during operation, and an emergency stop button to cut all power to the peripherals. Additionally, the HMI is located on the left, which is used to display the status of station components and provide mode selection options to the user. The Maximos display on the right is used to monitor force and distance feedback from the press. From this angle, we get a better view of the nut runner controller, and revised HDPE differential housing support plate. The exterior of the primary controls cabinet features a lockout-tagout enabled power cutoff switch. Inside, the system's logic is controlled by a Siemens PLC. The new table retention solution keeps the table attached with hinges and locking bolts. The HMI and Maximos displays were mounted on locking hinges to allow for ease of adjustability and increased security during transportation. While the team finalizes the setup process for press and nut runner manual operation, GKN will need to modify some of the programming to have everything functioning to their standards.